Hi, this is a simple circuits tutorial for all of you who wanted some help. I thought it would probably be better to do a video. You can work through this at your own pace, and then you can come and talk to me about it. If you've got any questions, we can do a face-to-face tutorial. I will produce a problem sheet, and there'll probably be a homework as well that goes through all of this stuff. Yeah, it's pretty important, but it's only one little bit of the physics. If it totally confuses you, you know, it's all right. Life's too short. We don't all have to be able to solve parallel and series circuit problems, even though I know you want to. Okay, so I'm going to go through calculations for series and parallel circuits. There are some important points that you need to know that you're going to use as tools for all your circuit calculations. First of all, know it, love it, use it. Ohm's law, V equals I times R. The voltage is equal to the current times the resistance. Yes, I know it is silly. I is current, but that's the way it goes. The units, volts, amps, ohms. Okay, Greek letter omega, because the unit ohms cannot be written with the letter O, because it will look like the digit 0. Amps, volts. Okay, voltage is also called potential difference, and in some books you'll see this written as U equals I times R. This is the basic formula you're going to use to solve all the problems. So if you're stuck in a test, if in doubt, just write down V equals IR. You might get some points. Okay, what about the rules? Well, a series circuit where you have got one resistor following another, a bit like a TV series, you got to know what happens in one to fully understand what happens in another. Well, most traditional TV series here, you need to. The total resistance is equal to the sum of the individual resistors. Okay, and if you've got more, you keep adding them on. Okay, add the resistances. Add the resistances. Main rule. Okay, you also add the voltages. So V1, V2, V3 gives you the total voltage. V1, V2 plus V3. Yeah, okay. And the current is the same at all points in the series circuit. Okay, the current is the same. I through all components. Yeah, so they are the logical rules that you have to apply for series circuits. Add the resistances, add the voltages, and the current is the same. Okay, I know it seems like a lot to learn, but you'll get used to applying it. Honest. So, what about a parallel circuit? In a parallel circuit, the current comes in, then it has a choice. It can go through a top resistor, R1, or it can go through a bottom resistor, R2. There might be more resistors, but then it reforms. So you have I going in, and it splits I1 I2, I2 comes out of the bottom resistor, I1 comes out of the top resistor, and they reform. Okay, no current is lost, no current is gained, so the current splits. How does it split? It actually splits in ratio to the resistors, but you can work all that out using V equals IR and these logic rules. So the current splits, then rejoins. Okay. The voltage is the same. Okay. The voltage is the same. Now that is a mess. I'm going to redraw it. Didn't want to draw it in red. I like purple. Okay. Let's say you've got 6 volts there. Let's say you've got one resistor here, another resistor at the bottom. Yep. 6 volts. Yep, now voltmeter. 6 volts from here to here as well, it's the same. 6 volts from here to here, it's the same. 6 volts across this resistor, 6 volts across that resistor. These aren't lines that you measure. You don't have to worry how long these lines are. This is the magic of a circuit diagram. It's an abstraction, it's a representation. All that matters are how many lines there are, and whether you've got a junction where you've got one going in and 2 or more coming out. Okay, these are wires. Wires can be all shapes and sizes. We assume the wires have got 0 resistance, so we can twist them around, and provided we don't break them or knot them and make these junctions any bigger, then we can move around, for instance, the wires on the voltmeter, and we just look at where they are in relation to the components. So the voltage is the same across each branch. Okay, so they are the rules that you need for the parallel circuits. Another thing, if you have a voltmeter, no current goes through it, and if you have an ammeter in a circuit to measure the current, then it doesn't affect the size of the current in any way. Okay, but we don't have to worry too much about that. It's just if you see them in circuit diagrams. So let's give an example, and I'm not going to put any values on here, so there's just going to be lots and lots of letters. So we've got our voltage V, that's our battery, yeah, and I'm drawing one resistor here. Then I am going to put 2 resistors in parallel, yeah, and I'll have another resistance at the end. Okay, our current leaves the cell, goes through the first resistor, it gets to this point, some of it will go through the top, let's call that I1, I2, I2, I1, and then they reform to make I. Okay, what are the sizes of I1 and R2? That is going to depend on what our resistances are. How about our voltage? Well, we've got 3 things for the current to go through. If you were part of the current, you were one of these electrons, we imagine you go through this, so you lose some of your energy, some of your voltage is used up. You get to here, you can either go through the top or the bottom, but whichever way you're going to lose V2. It's the same for the top as it is for the bottom. And then here V3. And the way that breaks up, V equals V1 plus V2 plus V3. Again, how much V1 and V2 and V3 actually are completely depends on whether on what size the resistances are. Okay, I'm just going to switch off the screen because I want to check this is recording. It is good, because I have already gone through this tutorial once and guess who forgot to get it recording properly. Okay, let's do some calculations now. This is the easiest circuit you're going to meet, the easiest type of circuit you're going to meet. You will have two things that you know and one thing that you don't know. So I have got one resistor connected to a battery, 2 amps, and we don't know R. We know 6 volts, we know 2 amps, we want to find R. It might not be wise to write WTF in a test in high school, but we're not in high school now. V equals I times R. You must write the formula, okay? Put in the unknowns. 6 is our voltage, 2 is our current, R we don't know, R is, then do your maths. If you're not sure about the maths, go see a math teacher. You need practice at doing these equations. This is really, really important, okay? If you're using the sad little triangle method I told you about, that's how it looks for this one, okay? But please try and understand how this works. R equals 3 ohms. Okay? So this is the simplest example that you're going to get. One unknown, 2 knowns, probably at a guess about a 7 standard. You are applying your learning, but it's not a particularly tricky one. Okay, let's take it up a step. Here we've got a simple series circuit. So I'm going to put 2 resistors into parallel. No, I'm not. I'm going to put 2 resistors into series. Sorry, this is just to keep you awake, you know, my deliberate mistakes. I need more coffee. So we've got a 5 ohms in series with a 7 ohm resistor, and I want us to work out the current. So what do we know? We know 5 ohms and they're 7 ohms and they're in series. We know 6 volts. We want to find I, the current. Okay, bit more complicated. We've got 2 resistors. They're in series. Know your rule. R is R1 plus R2. They're in series, we add them. So R is 5 plus 7, it's 12 ohms in total. Now we've got a single value for the resistance, 12 ohms, and we have got 6 volts. We can do V equals I times R. You must write it down. Okay, and we've got 6 equals I times 12. I is 6 over 12, which is 0.5 amps. Okay, now how do you show your logic and your working? Well, you could get lucky and just write down, because you could do it in your head, I equals 0.5 amps. You're not going to get all the marks. You have to somehow demonstrate what you are doing, that you have added up the resistors first of all. That's a major application of physics. You're knowing that series resistors add together. Show it. Then you are applying Ohm's law. Show you know Ohm's law. The maths isn't so important. You don't have to get the right number, but show the calculation you're doing, that you know that the voltage was 6, the resistance was 12. Do some sort of calculation, put an answer with the unit. Of course, you should get the correct numerical answer. Okay, let's do a second example that's a little bit more tricky. Yeah, here we'll have 10 volts, and I'm not going to tell you the current, so you're going to want to find that. And we'll have, just looking at my notes which have just slipped, 2 ohms, 3 ohms. Yeah, what is the voltage across the 2 ohms? So I'm after 2 things. Yeah, so you know 2 ohms, 3 ohms in series. We don't know I, you know it's 10 volts. I, you don't know, and V across the 2 ohms, we don't know. Okay, to get V across the 2 ohms, we've got to know I. How do we do the 2 and the 3 ohm resistor to get I? Well, they're in series, so add them. R equals R1 plus R2. So our total, 2 plus 3 is 5 ohms. Yeah, that's our first step. So, what is I? We know V is 10 volts for the whole circuit. We know the whole resistance is 5 ohms. So V equals I times R. 10 is I times 5. I is 2 amps. So now we know the current. What good does that do? Well, we know the current through there is 2 amps, and we've got a 2 ohm resistor. So for the 2 ohm resistor, V equals I times R. V is 2 times 2, so it's 4 volts. Okay, 3-stage calculation there. Add up the resistances, find the current, work out the voltage across the first resistor. Now, then you could take it one step further. Across the 3 ohm resistor, what would you have? Well, you can do it 2 ways. You can either do it the same way, that you know you've got 2 amps going through it and the resistance is 3 amps, so you've got 6 volts. Or you can use our voltage rule, V equals V1 plus V2. Our voltage across the whole circuit is 10, and our voltage across the first, we've just worked out, is, what was it, 4 volts, so our next one must be 6. 10 is equal to 4 plus V2, V2 equals 6 volts. Okay, either way, doesn't matter. I know I didn't ask you for that, but I wanted you to have a go at it. Okay, so let's have another example. Okay. So, just checking my notes. 12 volts. Eight ohms. 10 ohms. V. Tell you what, have a go at that. Pause the video. See if you can do it. What is V? Okay. Did you get it? For the the whole circuit. V is 12 volts. R, 8 ohms plus 10 ohms. They're in series, add them together. I, we don't know. V equals I times R. So 12 equals I times 18. I is equal to 12 over 18, which is 2/3 of an amp. I like a pretty fraction like 2/3 of an amp rather than a recurring decimal. Okay. For the 10 ohm resistor, the current is the same because it's a series circuit. So I is 2/3 of an amp. R is 10 ohms. V we don't know. V equals I times R. 2 over 3 times 10. So that is going to be 6.67 volts. 2/3 times 10. Think about the maths. Okay? Did you get that? Have we got a happy smiley face? I hope so. Right. Harder example. What if we don't know the value of one of the resistors? What if we've got 24 volts, we've got 10 ohms, we have a resistance of value R, and we have a current of 2 amps, and I want you to find the voltage across the 10 ohms, and I want you to find R. Okay, so our big problem is going to be finding R. That's a bit more difficult, but our value of voltage should, I hope, be quite straightforward to you. Okay, so two things. So what do we know? We know the whole circuit has got 24 volts. It's got a current of 2 amps. It's in series, so same current all the way through. We want voltage across 10 ohms, and we want R. Okay, so let's find this voltage first of all. If we do V equals IR to this first resistor, we can find V immediately. So V equals I times R is gonna be current 2 times 10, 20 volts. Okay, sorted. So we now know this is 20 volts. Okay, how can we do this again? Well, we want R. How can we do this? Well, for R, we need to know it's got 2 amps going through it. What's its voltage? To do this. Okay, we know 2 amps. We need V, the voltage across it. How do we do that? Well, remember our voltage rules. 24 volts is equal to, that's the total voltage across the circuit, is equal to 20 volts plus V. So V is equal to 4 volts. Sorted. This voltage plus that voltage is equal to the total voltage. Sorted. Okay, so V equals I times R. and we have 4 equals 2 times R. R is equal to 4 divided by 2, which is 2 ohms. Okay, you can do that another way by working out the total resistance of the circuit by saying 10 plus R times 2 gives you 24. You can do it either way. Check it and see if you want to. I think this way I've done is a little bit more straightforward. Okay, parallel circuits. Okay, if you can hear a buzzing, I apologise for that. I'm trying to keep one of my cats away from this touch screen. Not an easy task. She's quite insistent. Okay, parallel circuits. Let's draw a simple parallel circuit. The simplest parallel circuit has 2 resistors in parallel and they're equal in value, which brings up something a bit weird about parallel circuits, as we'll find. Let's say that that's 12 volts and these are 3 amps. Yeah, so what's the current? Okay, what's the current? We know 12 volts and we've got 3 ohms in parallel with 3 ohms. That's the maths symbol for parallel. I hope you have got that. I hope you've met that before. We want to find total current I. Okay. So, how do we do that? Well, our current is going to go to this branch. Some of it's going to go at the top, some of it's going to go at the bottom. I1 goes to the top, I2 goes to the bottom. Yeah? That's one of our rules for parallel circuits. The current splits and reforms. Second rule is that the voltage is the same. So our voltage is 12 volts here, 12 volts there, because it's 12 volts from here to here, from here to here as well. Okay, so the voltage is the same. So do V equals IR to the top resistor. Yeah, because we know it's got 12 volts across it. We know it's 3 ohms. We don't know what the current is. So 12 is equal to the current times 3. I is equal to 12 over 3, which gives us 4 amps. Same for the bottom. And you've got V equals I times R. You've got 3 ohms, current I. This is I2 in this case. And we've got 12. So I2 is also 4 amps. Hey, it was obvious, you know, they're equal resistances. They've got to have equal currents going through. So the total current is 4 amps plus 4 amps equal to 8 amps. Okay, so that's a little bit weird actually. We had 2 resistances, 3 amps, 3 ohms, 3 ohms, sorry, yeah, and they've got 8 amps going through, and our voltage was 12 volts. Okay, so that is the same as one circuit, if we want to simplify it, of one equivalent resistance. Yeah, electrically they're going to be similar. What would that equivalent resistance be? V equals I times R. If we replace these two parallel resistors with one, it would be 12 is equal to 8 times R. R is equal to 12 over 8, which is 1.5 ohms. So the total resistance here, 1.5 ohms, which you get by adding 3 ohms in parallel. Weird. Okay, you don't have to understand why, it's just a wonder, a little joy of circuits. Okay, time for a quick gulp of coffee. And now the next circuit that I want you to do, or we'll have a look at. This is slightly more complicated. So what we'll have in this case is two resistors of different values. So the currents going through the parallel branches aren't going to be the same. Let's have 3 ohms at the top, 2 ohms at the bottom. Yeah, and I want you to find the total current. What is the total current? Okay, so what do we know? Total voltage, 12 volts. Yep, and that's the same across each parallel branch. There's 12 volts across the bottom resistor and 12 volts across the top. And we've got 3 ohms in parallel with 2 ohms. Let's split the currents, I1, I2. Yeah, and what do we want to find? I, which is our total current, I1 plus I2. Okay, so for the 3 ohm resistor, we have Ohm's law, V equals IR, write it down, impress the person who's marking it. We have 12 volts, it's the same because it's from the battery. Sorry, we don't need the units there. You can put it in, you don't have to. So I1 times R. So I1 is equal to 12 over 3, which is equal to 4 amps. For the 2 ohm resistor, we have V equals I times R. Same voltage, different current, I2, and R is 2 ohms. So I2 is 12 over 2, 6 amps. So our total is going to be the 4 amps through the top and the 6 amps through the bottom. That's plus 6 amps equals 10 amps. Okay, so if you think about the physics of it, 4 amps, 6 amps, you got more going through the bottom because it's got lower resistance, it's 2 ohms, so it's easier to go through the bottom, and they actually split up in the ratio of 3 to 2 inversely, 6 to 4. So you've got 3 on the top, 3 ohms on the top, so 6 amps goes through the bottom, and 2 on the bottom, so 4 amps goes through the top. It's twice as difficult. Okay, sorry, not twice as difficult, 1.5 times as difficult. Okay, coffee gulp there. Okay, I'm going to give you an example to have a go at, and then you can pause the video while you have a crack at it. 20 volts across 12 ohms at the top and 8 ohms at the bottom. Yep, and I want you to find the current. Okay, So pause the video. I will wake up the cat, who is now snoring, and we'll go through it in a minute when you're done. Okay, so we want to find I. We know 20 volts is the voltage across the top. It's the 20 volts across each branch as well. And we've got 12 ohms in parallel with 8 ohms. So take the current separately. Our total current is I1 plus I2. So for the 12 ohm resistor, V equals I times R, it's going to be 20 equals I1 times 12. So I1 is equal to 20 over 12, which is 5 over 3, which is 1.67 amps. Ugh, horrible recurring fraction. And for our bottom resistor, V equals I times R, and we have the same voltage because it is 20. We have I2 times 8, so I2 is equal to 20 over 8, which is 2.5 amps. So our total I, 1.67 plus 2.5, which is 4.17 amps, I hope. Sorry if I've got the maths wrong. But that's the method. Add them up. I1 and I2. Okay. Are we happy? Happy smiley face? Hope so. So let's put them together. Let's do a series and parallel combo. Okay. $12 volts, yeah, and we'll have 2 amps going through a 5 ohm resistor, which is in parallel to a couple of resistors, and I'm gonna be kind, I'm gonna make them equal, yeah, and I want you to find out, I don't want you to find that out, sorry, what is R? What are the values of those resistors? They are the same. They are the same. Okay. Gulp. How do you do it? Do not panic. Okay, this is perfectly within your logical capabilities. Yeah, and there are actually a couple of ways to do it that you might find. So we're going to see which you're going to do. I personally would like to go through the voltage approach. So I would work out, first of all, what V1 is. This is the first place where you have to be active in the circuit, V1. Then the second place where you have to be active is V2. So they are going to be the places where the electrons are going to give up their energy. And we know the voltages add, so 12 equals V1 plus V2. Yeah. Once you know the voltage V2 across these resistors, you can, if you know the current, get R. How are you going to know the current? Well, I've been fairly kind to you here. 2 amps goes here. 2 amps is split into half because these branches are equal. So you do know the current through each of those resistors. You have to find out the voltage. Okay, so let's go back for our 5 ohm resistor. We know the resistance, we know the current is 2 amps. We want to find V1. V equals I times R, and V1 is equal to 2 times 5, so that is 10 volts. If V1 is 10 volts, here, we know that now, then V2, well, we can work that out. V1 plus V2 equals our total. Our total is 12, V1 is 10, V2 must then be 12 minus 2, V2 is 2 volts. Okay, so it's 2 volts across the bottom, it's 2 volts across the top, it's the same. So for R, we know the current is 1 amp, we know the voltage is 2 volts, so V equals I times R. 2 is equal to 1 times R. R is equal to 2 ohms. So we've solved our problem there. Okay, so you've been given enough information to solve the problem. You've just got to approach it logically. Okay, so I will set a sheet for you to do and work out the answers, and you can get back to me if you don't understand bits and pieces of it, and I'll see you face to face. If you are some random person who is not in one of my classes, who stumbles across this through the magic unicorns of the internet, then that's my email. You can contact me, and if I'm able, I will get back in touch. So I hope that has been helpful. Have a nice day.